So at some point you learned about proportions or ratios, possibly in 7th grade. It's really big in 7th grade. You don't have to write this. You can if you want, but you don't have to write this part. So let's say you have something that's like 1/2 equals x over 6. Class, what is x equal to? What is it equal to? 3. How do you know that this is equal to 3? Because it's equivalent, right? So like 1/2 is equal to 3 over 6. Because if you reduce 3 over 6, you're going to get 1/2. Another way you can figure it out is ask yourself 2 times 3 is 6. So what you do on the bottom, you do to the top. 1 times 3 is 3. So x has to be 3. Now, let's say we were going to cross multiply. So now I want you guys to actually do the cross multiplication. So write this down in red. 1/2 equals x times 6. Let's pretend you couldn't do that mentally and you forgot how to solve this. You would cross multiply 2x. 2 times x is 2x. 1 times 6 is 6. And you can only do this if there's an equal between the equivalent fractions. You cannot do this if it's plus or minus or times or divided by. You can only cross multiply when there's equality between the fractions. And now you could just solve this simple equation. You just divide both sides by 2 and you get x is equal to 3, which we knew all along. Now cross multiplication comes in clutch when you have a decimal of some sort. So let's say you have 1/2 equals x over 5.5. You could probably do that mentally. What's half of $5.50? Well, $2.75. That's logical. But, you know, just for argument's sake, let's cross multiply to make sure. Two times x is 2x. 1 times 5.5 is 5.5. Divide both sides by 2. X is equal to 275. All right, now here's another example. So remember, this is ICA test prep. So this video covers a lot of topics because your ICA covers a lot of topics from, let's see, geometry all the way down to like grade 6. So we're kind of jumping everywhere. So let's do this example. 3 times x minus 2 squared. And I'll tell you first what not to do, okay? What not to do. So don't write this. I'm about to write a big old mistake in red. Do not write. Just look at what people will do. I've seen people do this, and I don't want you guys laughing because if you don't know how to solve something, at least you're trying, but this is like a travesty. I've seen this mistake where people do this. They do like 3x minus 6, and then they put the square, and then they end up just doing like 9x squared minus 36. Or they make some type of mistake where they just go like, oh, the square is here, and they'll go 3 times x squared minus 2 squared. And they'll do something like 3 times x squared minus 4. And then they'll do like 3x squared minus 12. This is wrong. This is wrong. And they'll come up with their own equivalent fraction or equivalent expression, and it's completely wrong. So don't write this and don't make any of these mistakes, folks. Let me teach you what you do. So every time you see an exponent, I need you to acknowledge that it's saying whatever is next to it, however many times this number is. So this is a 2, so it's basically saying x minus 2 times x minus 2. That's what it's saying. So expand it first. And since the 3 is outside, the 3 isn't getting expanded. So this is x minus 2 times x minus 2. Just rewrite it. And then when you're multiplying polynomials, you should remember that you either use FOIL or the box method. So I'm going to use both of them. So FOIL stands for first, outer, inner, last. And I think it's like these first ones. What's x times x? X squared. Outer are these two. Negative 2 times negative 2 is? Positive 4. And then inner, what's negative 2 times x? Negative 2x. And then outer, like this one and this one. X times negative 2 is negative 2x. Now, can't you combine those? The ones in the middle? So you could have 3 times x squared minus 4x plus 4. Personally, I don't like FOIL. I like the box method. I'll show you the box method right now. But let's finish this. Or actually, let's go to the side and let's do the box method. So you have x minus 2 times x minus 2. Do you guys agree that that's a 2 by 2 box? Because you have 2 terms and 2 terms. So x minus 2 and x minus 2. So here you just multiply the corners of the boxes. So x times x is x squared. X times negative 2 is negative 2x. Same thing here, negative 2x, because it's negative 2 times x. And then what's negative 2 times negative 2?
4.
4, positive 4. And then the diagonal, like you can combine these two. So what is it? It's x squared. What's negative 2x plus negative 2x?
Negative 4.
Negative 4x plus 4. Do you see how this green matches what you did with FOIL? So they both work. It's just all up to you what you prefer. Now I can finish this and I can distribute the 3. 3 times x squared, 3 times negative 4x, 3 times 4. And that should get you 3x squared minus 12x plus 12. Now the question on your test is not going to ask you to just expand this. That's not your only answer. It's going to give you a list of all these expressions, and it's going to say which ones are equivalent to 3 times the quantity x minus 2 squared. So you need to remember that I'm going to write it in blue right now. Actually, let me think of another color. Yeah, let me do this bright lime green. So this expression is equal to this expression. And it's equal to this expression. And it's equal to this expression. And it's equal to this expression. All of those are equivalent expressions. They're just different forms. So it's your job on your test to recognize which of the given expressions are all equal to each other. So stay organized. Okay? Now the next thing I'm going to talk to you guys about is inequalities. And I'm just going to review 2 things with you with inequalities. When you solve inequalities, it's like solving an equation, except if you multiply or divide by a negative, what happens to your inequality? It flips. Okay, you guys remember. So here's a simple inequality. X plus 6 is greater than or equal to negative 12. Now, if I'm going to solve this, what's my first step? Subtract 6 from both sides. And I get x is greater than or equal to negative 18. And I'm done. Unless they ask me to graph it. If they ask me to graph it, I would go to negative 18. And since I can actually plug in negative 18 right here, negative 18 is equal to negative 18. So that means I can shade it in. So I would do an open circle. And I would shade it in. And now I'm going to shade in the direction that makes the inequality true. So what numbers are greater than negative 18? Any number to the right. So I would shade to the right. If they ask you to graph. I don't think your test has anything like this, but it's still good to know. Now, what I really wanted to review with you is this. Let's say you have negative 2x plus 6 is greater than negative 2. Now, remember, your inequality flips when you divide or multiply by a negative. Only divide or multiply, though. So I'm going to start by subtracting the 6 first. And then I'm left with negative 2x is greater than negative 8. Now, in this step, I'm dividing by a negative number. Since I am dividing by a negative number, what happens to my inequality? It flips. So flip only when you divide or multiply by a negative. So now I'm left with x is less than negative 8 divided by negative 2 is 4. And if I were to graph that, is it an open circle or a closed circle? It's open because is 4 less than 4? Can it be? No, it's only equal, right? So it's not included. So what is a number that's less than 4? So in the left, you would shade that way. So here's a little tip for word problems, because there are 6 of them on your ICA that I counted. There might be more though. So whenever you have a word problem, there's always something that has a variable that's changing. So they might have like a rate, or like something that's like mile per hour, or kilometers per minute, or like basically it's a variable that is dependent or changing. Like bowling, for example. I'll give you that example right now. So if it has a variable or like a number that changes depending on how much you put in, attach a letter or variable to the quantity. It's really sloppy, but I think you guys know what I'm saying. So here's your example. I'm just going to give you a quick example. Pretend there's like a paragraph. It's a word problem and you freak out. Oh my gosh. But inside the word problem, it's basically telling you this. You go bowling and it costs $10 for a pair of shoes. And each game, they charge you $8 per game. Write an equation that represents this total cost for C. Okay? Now, that sounds crazy, right? Like, write an equation for the total cost C. But it's not that hard. Like, think about it. The cost equals $8 per game. So which one am I going to put a letter on? The 8 or the 10? The 8, because it all depends on how many games I play, how many 8s I play. So I would do 8. And I can put X, but what's another letter I could use for games? G. 8G. And then what do I have to pay no matter what? The flat rate. The $10 for the shoes. And then I'm done. Now the flat rate always just gets added or subtracted. Like, oh, it's $50 to rent a car, and like $50 to rent a car. Just for the rental. But it costs $1.50 per mile. Give me an equation for the total cost using the letter Y. Y equals what?
150M.
150M
Plus
plus 50, because you only pay that once, right?
Yeah.
Okay, cool. That's it.
That's it.
So most word problems, I'm not going to say all of them, but most of them give you a rate or something that you need to attach a variable to. And then you just got to pay attention to the other letters. Like, oh, what do they want you to write as on the other side of the equals? And what's that one-time fee? At least that's a pattern that I've seen throughout the years.